Okay, this is the video for section 8 in the review chapter in your book. And at this point, we have covered how to solve linear equations, how to solve quadratic equations. We've looked at linear and quadratic applications. Now we want to, well, the way it works in math is generally, once you know how to completely solve an equation, which we do, and we've done it, then you want to look at how to solve inequalities and see if the algebra is the same or if it changes. So to start, suppose we have 2x plus 4 equals 10. And I know you all know how to solve that, but really quickly, algebraically, what do? I subtract the 4, so I get 2x equals 6. Then I divide the 2, and I get x equals 3. All of you can do that, that's not a big deal. Now, instead of looking at the equation, we want to look at the inequality. 2x plus 4 is less than or equal to 10. And as far as it goes, if the algebra worked over on the left with the equation, then it should work right here. So we do the exact same thing. Subtract the 4, 2x is less than or equal to 6, divide the 2. X is less than or equal to 3. If the algebra works there, it works here. The only real difference is here when I say x equals 3, I get one solution. Here when I say x is less than or equal to 3, I get an infinite number of solutions. 3, 2, 1, 1.8, 2.7, etc., etc. You guys get the idea. But the key point here is all the algebra you know that you did before will work the exact same now. So, suppose we have, we'll do like a couple examples of this. Suppose I have 2x plus 3 times x minus 4 is greater than 3x plus 5. Solve that. Well, again, all we really do is pretend this is an equality and do all the same algebra I'm used to. So we'll distribute the 3 in. 2x plus 3x minus 12 is greater than 3x plus 5. Now, if this was an equation, I would combine like terms, so do that. 2x plus 3x is 5x minus 12 is greater than 3x plus 5. Then let's see, if this was an equation, I would bring the x's to one side, the constants to another. So do that. Subtract the 3x. 5x minus 3x is 2x is greater than, add the 12. 5 plus 12 is 17. And then divide the 2. X is greater than 17 over 2. And one thing, as far as it goes, once we start talking about inequalities, there's multiple ways to write your answer. This is one way, just writing it as an inequality. A lot of times your book and Alex in your exam will say to write things in interval notation. So in this case, x is greater than 17 over 2, which means I want the numbers from 17 over 2 out to infinity. And then I just have to put parentheses or brackets around those numbers. And the way it works is, if this is a strict inequality, I'm not including 17 over 2, so I draw a parenthesis. If this was greater than or equal to, I would draw a bracket. That tells me to include that endpoint. But we'll erase that so there's no confusion. And as far as it goes at infinity, you can never include infinity. All of you know that's an idea, not a number. So I always draw an open parenthesis there. You can also do this with a number line. On a number line, 17 over 2, that is 8.5. So we can just do something like 7, 8, 9, 10. 17 over 2 is right here. I'm going to draw it above the number line just because the markers will get all messed up. So we'll say this is 17 over 2 right here. And I draw an arrow because I want all the numbers greater than 17 over 2. And then when drawing this on a number line, you either draw that as an open circle or a closed circle. If it's a strict inequality, if it's just greater than or less than, if there's a parenthesis here, you draw an open circle. If this was a greater than or equal to, if I had a bracket here, I would draw a closed circle here to include that point. As far as it goes, I'm generally fine with just writing something like that. But like I said, sometimes in your book and on your exam on Alex, it will tell you explicitly, write them on a number line, or a lot of times write them in interval notation. So just make sure you know how to use each type of notation. Now, there is one trick that pops up, and we want to make sure to go over that. So, suppose I have 2 times x plus 4 plus 3 is less than or equal to 5x minus 6. I want to solve that, so I distribute. 2x plus 8 plus 3 is less than or equal to 5x minus 6. Combine the like terms on the left, I get 2x plus 11 is less than or equal to 5x minus 6. Now bring the x's to one side, constants to another. So subtract the 5x over. 2x minus 5x is negative 3x. Is less than or equal to negative 6 minus 11 is negative 17. Now I want to get the x by itself, so I divide by negative 3. And I get x. Negative 17 divided by negative 3, 2 negatives cancel, and that's positive 17 over 3. And then there's just one trick here that pops up. If, when you are solving your inequality, on the last step, you multiply or divide by a negative, you flip the inequality around. So instead of being a less than or equal to, it's a greater than or equal to. There's actually another way to do this to see that more explicitly. Right here. From this line. Essentially the problem came up when I subtracted the 5 over to the left and I got a negative. If I want to avoid negatives and maybe having to deal with this rule, or if I'm not sure how it works, just keep all my x's positive. So in this case, subtract the 2x to the right. Then I'll add the 6 to the left. So on the left I'll get 11 plus 6, 17 is less than or equal to 5x minus 2x, which is 3x. Then I divide the 3, and I get 17 over 3 is less than or equal to x, which is the same as x is greater than or equal to 17 over 3. So we see here, if I hadn't switched this inequality around and left it like that, those would be different answers. So I have to switch it to keep things the way they're supposed to be. Again, all you really have to do is, if you are solving these out, if you get a negative coefficient of x, when you divide or multiply by it, switch your inequality around. If that rule confuses you, just always make sure to bring your x's to whatever side of the inequality will make them be positive. Then you'll never have to deal with the rule. Okay, there is another type of inequality we want to look at. The ones we just did are called simple inequalities. Now we want to look at compound inequalities. And the idea is, maybe I have something like 2 is less than or equal to 3x plus 4 is less than or equal to 8. This is just called a compound inequality because there's 2 different inequality symbols. As far as solving it goes, there's 2 ways to solve it. One way is to say, there's 2 inequalities, so this really means I have 2 problems to solve. 2 is less than or equal to 3x plus 4, and 3x plus 4 is less than or equal to 8. Problem is, if I think about solving that, well, here I want to get the x by itself, so I subtract the 4. 2 minus 4 is negative 2, is less than or equal to 3x. Then I divide the 3. Negative 2/3 is less than or equal to x. Here I want to get the x by itself. I subtract the 4. 3x is less than or equal to 8 minus 4, 4. I divide the 3. X is less than or equal to 4 over 3. And now I just get those 2 answers, and then I combine them. Negative 2/3 is less than or equal to x, which is less than or equal to 4/3. And if you want to do it that way, that's completely fine. But if you think about it, to get from the first line to the second line, here I subtracted 4, here I subtracted 4. To get from the second line to the third line, here I divided 3, here I divided 3. Which means I did the same algebra on both inequalities. So from a mathematical perspective, if you're doing the same thing on both lines, then just do it all at one time. And then all I really say is, I want to get the x by itself in the middle. How do I get it by itself? I subtract 4. So I will subtract 4 from all three parts. 2 minus 4 is negative 2, is less than or equal to 3x, is less than or equal to 8 minus 4, 4. I still want to get the x by itself, so now I'll divide by 3. But I'll divide all three parts by 3. Here I get negative 2/3 is less than or equal to, the 3's cancel here, so that's x, is less than or equal to 4/3. And I've already erased it, but you probably have it in your notes. That's the exact same answer we got when we did it separately. Negative 2/3 is less than or equal to x. X is less than or equal to 4/3. We just did it all in one shot here. And all that means is, this is my answer, and when I set up an interval for my solution, since both of these are less than or equal to, greater than or equal to, I use brackets, and I go from negative 2/3 to positive 4/3. As far as it goes, that's pretty much all we need to know for these linear and compound inequalities. Treat them exactly like you did regular equations, even if you have 3 of them just like this. The only trick to remember, if you multiply or divide by a negative at the end, make sure to flip your inequality around. There's one more type of inequality we're going to look at, but this video is already too long. I don't want to add another thing to it, so I'm going to make another video covering that.